Okay, so today we're going to be talking about section 3-2, which is solving systems of linear equalities. Okay, so skills that you're going to need to know today is number one, to be able to graph a line. Okay, so can you graph a line? And then skill number two, shading, right, which we've already done, which is either above or below. Okay, so those are two things we're going to need to know how to do today. So let's start, and we're just going to have some practice. Today we're just practicing in class. So, not an equal sign. We're going to have the first equation be this. So 2x minus 4, and then y is less than or equal to negative 0.5x plus 3. Okay, so on your paper right now, pretend those are just regular lines, and graph those two using the graphing method like we've been doing the last couple days. So on your graph paper, let's try to graph that using the graphing method. Now, this also brings into play inequalities are solid lines or dotted lines. So when you're graphing them, you got to think, is it solid or is it dotted? Solid is an equal to. Dotted would just be a greater than or a less than without the equal to. Okay, so one thing I can do here on this problem, let's graph the first line. You guys all probably know how to do that one. Okay, so I'd start at negative 4, and then I would go up 2 over 1, up 2 over 1, up 2 over 1. Okay, and then is that solid line or dotted? Dotted, so this is going to be a dotted line. Okay, if you got your ruler out. Okay, you got your dotted line. Okay, and that is dotted because there's no equal to on that guy. Okay, we're going to come back to the shading part in 2 seconds here. I'm going to graph the other line next, and then we'll talk about it. There's a couple ways that you guys can do this. Okay, so since this is systems, since this is called systems of linear equations, we're going to do the same, on the same graph, 2 equations of a line. Okay? What's the y-intercept in the second equation? 3, right? So I'm going to take my dot here. Now here's the 2 things you can do. What's 0.5 as a fraction? So I don't like that. What would that be as a fraction? Half. And now does that make it easier for rising over run? Huh? You don't have to. You can leave it as 0.5 too. So I could go down 0.5 over 1, right? Down 0.5 over 1. Isn't that the same as down 1 over 2? See that turned into the same thing? You just had to do, you do twice as many dots with that 0.5 versus the 1/2. Okay? So, I'm just going to go down 1 over to the right 2. Okay, is this a solid line or dotted? Solid. This one's solid, and you'd go up 1 and back 2 to get to the other one. Okay. Now before on the graphing method when I did this, where was my solution when they were just equal to? So if it was just equal sign, it was where they what? Where they intersect or crossed, right? Okay, but now I have inequality. So the reason why it was just like that, because there's only two lines that had dots, right? When they're inequalities, it can be anywhere, and that's why we shade, because there can be any points anywhere. So let's think about this red line here. Okay, so let's go back to the first line. This is the red line here. Is my y greater or less up there?
Greater.
Greater. Which direction is greater, up or down? Up. I'm going to do a crayon here. So I'm going to shade up now. I'll show you two ways of doing it. One way is you can do it like a light shade above here. Light shade, because we're going to actually shade the common area. So when the two lines meet, that's a common mark, right, where that dot is. Now it's going to be where do my two lines shade in common. That's my solution for both of them. Okay, so let's go to the blue line now. Okay, so if I go to the blue line, what is this y? Is y greater or less on the blue? Less. Which direction is less, up or down? Down. So now my blue line is shaded below, right? So,
How do you tell the difference?
where are they common right now? Where are they both shaded? What area are they both shaded in? So you see how here it's just red? And you see how down here it's just blue? Where are they shaded at the same spot at? You see how this section is where they're common? Okay, so that's going to be your solution. Okay, so you would make this area really dark if you shaded both. Okay? So now here's the deal. You don't have to erase this, but this is actually not shaded. That's just for the blue line. And this red line up here is also not shaded because that's just for the red. We're only looking for their common area. And again, you could pick a point, just like before, we could pick a point where the lines would like touch and land on there. We can pick a point anywhere in the shaded area. So like the origin is right here.
Lakin, Bruin, will you please come to the office? Lakin, Bruin, please come to the office.
Okay. So we can pick any point on this graph that's in that shaded area and test it, and it would work out. So if I were to plug in 0, 0 for both of these, it'd be 0 is greater than 2 times 0 minus 4. Is 0 greater than, that's 0. Is 0 bigger than negative 4? Yep. And then if I plugged a 0 into this equation, it'd be 0 is less than or equal to negative 0.5 times 0 plus 3. Well, that turns to 0. So is 0 less than or equal to 3? Yes, so they're both true. So wherever both solutions are true, that's where you would shade. So technically you could test all 4 areas and see which one would work. It'd be a little more work. Questions on that one? All right, let's try another one and practice one. I'll let you actually work it out and do the shading on this one too. So you gotta remember everything, solid line, dotted lines, and then the common shaded area. Here's another way of doing this. I'll tell you one other way that I do it so you don't have to shade everything. Okay? So if I were to do this without shading, I know the blue line right here is less than, so I sometimes just put arrows to the direction of where it's going. Okay, and then the red line is shaded greater, so that would be above, which would be here and here. Where do the arrows meet? You see how these two arrows meet together in this section? That's another way of doing it, and then you don't have to shade everything. So either do light shades on both, and where they're common, make it darker, or you can just put little arrows in to say where it's going to shade, and then just shade that one section. All right, so next question here we're going to practice is this one. So y is less than or equal to negative 2x plus 5, and y is greater than negative 1/4 x minus 6. Okay, on your paper, graph those two inequalities, solid line, dotted line, and then shading. And notice both of these lines have negative slopes. So when you draw them, they should both be going downward in the downward direction.
Jeez.
Kids these days, I tell you what. I think this is supposed to be dotted, so I'm gonna have to erase it. Right, is the second one dotted?
Yeah.
Yep, so. Okay, so second line is dotted. Alright. Hardest part now, right? You gotta figure out where it's shaded. So I'll do the shading the other way that I do it now this time. So instead of shading both and then doing the darker area, I'll just do the arrows. So that's another way of doing it. So this first equation says y is what?
Mrs. Harwood, would you
Yes.
please call 102? Mrs. Harwood, 102.
Yeah, no. Alright. Y is less than or equal to, right? Which way is less than? Down. Okay, so that's this direction, right? So if you could just put a couple arrows, you know you're gonna shade down in that direction. Okay, I'll pick the blue line now, which is dotted. What does this one say? Y is what? Greater. Which way is greater, up or down? Up. So now I'm gonna put point arrows. You see I kind of go both sides of the line? Where are my arrows combining and kind of meeting together at? You see in the middle right here, this red one and this blue one are like pointing at each other. That means automatically now it's gonna be this. That's my shaded area. Okay, so that would be my shaded area. I'm gonna get that one right, raise your hand. Okay, questions on that? All right, let's try another one, practice problem. Ooh, this is a good one. All right, there we go. Graph both of those. Number solid or dotted. What shape does an absolute value make? A V, yes.
What?
So that top one should make the letter V. Do you guys remember solid lines or dotted lines? Yeah, usually when you guys do these, and you're solving them and you're graphing them, finish the lines out on your graph so it like fills up this whole square. That makes sense? And then shade it to the edges of the square on your graph.
I don't get the sheet.
So on the first one, your y is what? So it's gotta give you your y and
It's a group.
greater. So which would be greater? Up or down? So right now, this one would be shaded up here.
Every
So you got the other one up, but when I on this side, I was on both sides of that.
Yeah.
Right? How much one's down, right? Do it on both sides, put it down there over here. Where they need now. Should I go both sides of each line? Alright, so if I'm gonna graph this first one, y-intercept of 5, up 1, 2, 3, 4 over 1, 2, 3, or down 1, 2, 3, 4, back 3, 1, 2, 3, 4, back 3, 1, 2, 3, 4, back 3. Solid line or dotted line on this linear equation here?
Dotted.
Dotted, yep, so dotted. Okay, dotted line. Let's go to the absolute value here. Okay, absolute value makes what letter we said? A V, okay? Starts where? 0, 0. And what's the slope? Mm-hmm. Up 1 over 1. And what's the diagonal to here? And then a diagonal to there. Okay. Let's shade now. So what does this say? Y is what? Greater. So I'm an arrow guy. I like to point arrows. I just pretty much point arrows on both sides of that blue dotted line. Let's go to the blue equation. Y is what here? Less. Which way is less?
Down.
Down. So again, I go to the blue line, and I pretty much put arrows on every side of the line. Where are my arrows matching up or meeting each other here? Middle, right here, right? Red. So my shaded area is gonna be right in that area there. How many got that one right?
Yes.
Yeah, we're getting more, good. Let's try another one here. Alright, try that one for me on your paper.
You're just munching out on that popcorn, huh?
Almost done. Gotta get that breakfast of a champion, right?
Yeah.
Remember solid lines or dotted lines?
Shut up. Yeah, send it.
Maria.
Alright, what do you guys notice on this one? What happened?
Same slope.
Same slope, they're parallel, right? When we shade, we always shade what? Their common crossing points, right? Let's graph this quick, then we'll look at it. Okay, so y-intercept to 5, up 1 over 1. Solid or dotted? Solid. Okay, next equation, I'll go red. -4, and then it's again up 1 over 1, right? Do you guys recognize those are parallel lines before you graph them?
Yeah.
Okay, you guys start recognizing that when you see that they're the same slope, you gotta know, oh yeah, now is this solid or dotted? Dotted on this one. Ooh, my line got a little off there, huh? There we go, that's better. Okay, first line, y is what here? Greater, that would be shaded where? Up here? Second line, where's less gonna be?
Down.
Down. Since these are parallel, the lines are never gonna touch, right? So if you think about, if we go back to,
Solution.
no solution. Nice work, because if we think about the lines before with our parallel lines, right? If they never touch, there was never a solution. The solution only happens when the lines intersect. So if they're parallel, it'd be no solution. And what was that word we used for that? Inconsistent, because there's no solution. Yep. So this actually would be no solution on that one because they never actually met up. Okay. Questions on that? Does everybody understand then everything we need to have for systems of inequalities? There's more than one equation. When we come back on Monday, we can also throw in third equations where there'd be another part. And now if there was a third equation, where would the common area be? Could be where they're sharing here and where they're sharing here. We'll throw that in on Monday though, okay? Alright, it is, yep. That's all I got for today.